We have to start behaving. I apologize, especially me. I'm always out of shit. All right, let's take a look at pages 3 and 4. I've marked it. What kind of questions have you come across?
What questions we have for you?
Yeah, well, on pages 3 and 4, yes.
Okay, cool. I had a little trouble on 27.
27. You know, that's the only one I forgot how to do. All right, number 27, here we go. So we have surface area, SA, equals pi r squared plus pi RL. I'll make that a fancy L. And then we want to solve for the L. Everyone with me? So this is what we want all along. Agreed? So looks like that first pi r squared, I can just move to the other side because pi and r squared is pi r. It's being held together by multiplication. So I'm just going to subtract that. Is that okay? So I'm still trying to get this by itself. So how are pi r and L being held together? Multiplication. So to undo it, I need to divide both sides by pi r. So here's your answer. Okay, because that would have canceled here, right? Cool. Good, I figured it out. I mean, I totally struggle with that one too. You're good. What other questions have we come across? Yeah.
30.
30. Oh, it's a story problem. This is going to be great. You know, I read 3 books in my lifetime. All right, it says, problem 27 represents the surface area of a right circular cone. Okay, so a right circular cone would be like a cone like this, or that's a 90-degree angle. Ooh, I am pretty artistic. I know you guys are impressed. There's no applause ever. You just have to throw money when you show appreciation. Okay? Let's see. And it says the surface area is 65 pi square inches. It's not catching up with me. I'm like writing so fast. And then my radius, they tell us, is 5 inches. Right? Okay, let's see if we can do this. We're going to go here. We're going to do dual display. All right, so we're going to use problem number 27 because they wanted us just to find, I believe, number 30. They wanted us to find the slant height. Well, being we already solved this one for L, that means I can just plug my information in. So I know surface area, they told me, right? That's 65 pi. And then minus pi, what was r? Oh, they told us it was 5. So r squared is? 25. Yeah, you guys are so smart. And then pi, still says pi, and then we know the radius is 5. All right. So let's see if we can do this right. So now I'm going to get 65 pi minus 25 pi. I just flip-flopped them. All divided by 5 pi. Does anyone see, like this is called a compound fraction because you have like an addition problem or a subtraction problem on top all over one denominator. So what do all the parts of this problem have in common? 5, what else? Pi. So I'm going to cancel the pi's from everything. And then I'm also going to cancel the 5. 5 goes into 25 5 times. 5 goes into 65. How many times? How much? 13. 13? Oh, and then I get 13 minus 5. 8. So I found I have a radius, no, not a radius, a slant height, excuse me. It's supposed to be a cursive L. I know you guys haven't had cursive because, we took that out of elementary school. Now no one can hold a pencil. Okay, slant height, 8 inches. Sweet. How cool is that split screen stuff? I'm having fun with this. This totally failed on me like my 7th period, or my 8th period Algebra 2 class. Those poor kids are going to be falling so far behind. You guys are like totally advanced. I'm going to be grading you guys getting all A's. 8th period, F minuses. Kid can't even spell his name right on his test. Name's John. How do you spell that? Kupching with the number 4. Oh. Okay. What other questions we have from the homework? I'm sorry, there's sarcasm in me. I apologize. Any other questions from the homework? Going once? Going twice? Okay.
I guess we were gonna discuss this in class, but is 3 like always negative or always positive?
Is what?
Is 3 always negative or always positive?
Number 3. Number 3. Oh, okay. That's a good one. Number 3. Is it always positive or negative? Nope. That's not the one. Let's go back to single screen. Single display. Oh my gosh, look at that. 30, or you said 3.
Yeah.
3. I'm making stuff up. Negative NP. So in the directions it says P is a positive and N is always a negative, right? Is that what we said? So let's just pick. It looks like we're multiplying, so it doesn't really matter the size of the number, right? So let's say we're going to call P we're just going to call positive 10. And we'll call N negative 9. It doesn't matter if I made, looks more like a 7, so let's stick with that. So I have this negative up front, so I get negative, right? And then if I plug negative 7 in for N and positive 10 in, what's my answer going to be? It's always going to be positive this way, and positive 70, right? Hey, so would it have mattered? Let's say this was like negative 70, and this was, so if I had oh my gosh, come on. Would it matter if we made this a much further to the left? No. So it's still going to be a positive answer. Okay, cool. I like it. Anything else? Going once? Twice? Yeah. 24. 24. All right, problem number 24 says we have I P 1 plus R raised to the T power, and we want to get P all by itself. Right? Everyone happy? All right. So P is being multiplied by this whole structure right here. So if I divide 1 plus R raised to the T on both sides, and notice I keep it grouped because I'm raised to an exponent. This and this cancel out, so I find that P is equal to this. Good enough? I like it. Anybody else? Going once? Twice? Sold to the kid who's eating his earwax. Looking around going, oh, no, it wasn't my ear, it was my nose. Yeah, I'm sorry. I'm sorry. All right. Okay, so that was 2 pages unless you actually have the workbook now, right? So let's separate pages 3 and 4. Okay, it doesn't matter if it has a staple in it or not. Make sure your name is on the top of pages 3 and 4. And pass pages 3 and 4 forward. Front row, you're responsible to make sure names are on the papers that are to you, including your own.
Wait.
I love him.
All good on names? All good on names? All good on names? Cool. And then when you get that done, just turn it in the next one. Good. Good. I know, rhythm going. You see that? It's like the old grandma at the mall during the holidays where you're like, yeah, wait. Kid. All right. Am I teaching okay so far?
Yes.
Has anyone crying themselves to sleep yet? Good. Let me know when you cry yourself to sleep. I know I do. I cry myself often to sleep. It's good. Releases endorphins. Alright, everyone have a note sheet? Did I count enough out? Okay, so again, these are your notes. Again, if you want to be that person who has the 5-ring binder separated into 16 different areas with all these neat tabs and you highlight everything, good for you. I don't really learn that way, so I'll never collect notebooks and say, hey, you have to have it my way or it's the wrong way. Your notes are your notes, so you place these how you want. And honestly, if I was given the same opportunity you guys were right now, having a skeleton of notes, I'd probably hold on to them, and then once we get to the end of the chapter, I'd probably put them in my room and say, okay, I'm going to study these when the final comes rolling around. But of course, if your room looked like my room in high school, you put something down, 2 weeks later, it's gone. It's buried under something, right? But I'm trying to give you a heads up, but I also am using the sarcasm because I'm that person. All right, so solving inequalities and graphing their solutions. So you know that inequalities are really something that us here in this country have no concept with. And the reason I say that is, and you'll discover this if y'all decide one day that you want to start bringing children into the world. There's something that is a must in society, and it's called diapers. And you're going to be frightened because you're at your last diaper and you have like no time left. You haven't slept in 6 weeks because your kid's colicky, which is, a coughing disorder, but, it's not always, a bad thing. At least for the kid. The parents hate it because you can't stop coughing. But you go to the store, you're like, I just need to run in and out. You got your kid in your arm. You grab the one thing of diapers. You're hoping it's the right size. You can't even see straight. And you're going to go to the 10 or items less than 10 or less items lane. That takes cash only. And you're happy because you got a 20 in the wallet and the price on these is $15.40. So you know you're set. And you're just about to the line and you got someone who ignores rules. They have the grocery cart that is heaped over. They have a fistful of coupons, and they're going to write a check. And you're just looking on going, could I get in front of you? And they're like, no, I was here first. Okay? Now, I just say that with sarcasm, but it's one of those things where you just look at people going, give some people some grace. I'm sorry, if you have a mounted shopping cart and you have somebody who's trying to hold on to their child in one arm and a thing of diapers and a 20 in the other arm, they have priorities that are a little bit more insistent than you. So this is where inequalities don't make sense because obviously they didn't read the sign 10 items or less and cash only. But we have to make sure we teach this to you because this is important because you don't want to be baby armed, or maybe some of you might have twins or triplets, and you're like, hey, look at this. I got a kid that I'm carrying on my leg, and you're hopping through the store, and you got the diapers in your mouth. You with me on this? I'm sorry. All right, so solve the inequality. So here we go. Let's have, I'm just trying to have some fun, a little sarcasm with it at the same time. So it looks like we have x on both sides. We do have, so problem number 1 is 2 quantity, 5x minus 8, greater than or equal to, so we're going to include the point, because you have the little equal sign underneath. 8x minus 6, so would you feel comfortable if I did this?
Yeah.
Okay, and this is like so algebra 1. You're like, dude, I totally get it. Okay? So we have to start solving it, so I'd probably say let's subtract 8x and bring it over, so that means I have 2x on this side. And then I could probably also add 16 to both sides, so then I'd get 10 over here. So I didn't write the steps down. I'm not writing the steps down because I want to confuse anybody. But does everyone feel comfortable that if I go plus 16, negative 6 plus 16 is 10. If I subtract 8x, 10x minus 8x is 2x. And then 2 and x are being held together by multiplication, so I'm going to wind up with my answer like this. So that's Algebra 1. And this is still kind of Algebra 1 here, where we're like, okay, well, I know 0's here. I know 5's here on the number line. I know because there's the equal sign, it's going to be a solid dot. And I know I'm going to shade it this way for my problem. And we're still locked in Algebra 1. And I think most of you would feel comfortable with that situation. Agree? Yes. But then they have this new thing. They say, hey, we want interval notation. And interval notation is just a way of writing it. It's something you'll use in calculus. It's a shorthand version of you actually graphing something. But interval notation looks like this. We're going to use a square bracket. And we're going to go from 5. And I'm going to go to the right. And that goes all the way to infinity. Okay? So the square bracket means we include the point. That's our starting point. We're going this way. So we're going to go to infinity this way, and that's why we use infinity. We always use a rounded bracket at infinity because of what reason? Anyone know?
You can't reach infinity.
Yeah, we're not going to get there, right? When you're a little kid, I wish I had infinity plus infinity ice cream. Well, that means you still have infinite ice cream. Like, no, it's to infinity. No, it's infinite. You're not going to get there. You're not going to get there, kid. Deal with it. Hey, can I move on? I'm sorry. Did I offend anybody yet? I mean, this is all being recorded, so we can go back and look to see if I said something incorrectly, which I probably did. That's why I record myself and I watch it at night. But I put it up on the big TV. It's kind of cool. Some of you are kind of thinking, he might be serious. Yeah, it's videoing right now. We're recording. It goes on YouTube. It's posted on Schoology. Thanks for listening yesterday, there, Mr. Farm Fresh Egg Boy. I called him Farm Fresh Egg Boy. You didn't even catch on. That's so cool. Now we go. Okay, nickname for you, Farm Fresh Egg Boy. Okay, we'll have to slow it down. We'll call you Sunshine. Okay. That's your nickname for the rest of the year. Sunshine. All right. Hey. Ooh. What should we do on this problem? Distribute what? The negative 3. And if you distribute a negative, that negative has to go to both items inside, yes?
Yeah.
And in Algebra 1, every kid is going to forget this. And I realized you guys were in 4th grade when you took Algebra 1. I get it. You get the one kid going, I was in 5th.
Yeah.
All right. Hey, do we feel comfortable with what happened here?
Yeah.
So let's start moving things around. Now, we're all older now, so we should be okay that if the x winds up on the right side, it's okay. But we always have to flip it. If you want to stick with the Algebra 1 approach, you probably say, well, let's move this on over, so I'm going to get negative 5x over here. And then let's move this over, so I'm going to get greater than or equal to. If I move that over, that's going to be 25. Is that okay? Now I'm going to divide by... Does anybody remember? I'll put this up here.
Flip the
What?
sign.
Who?
Flip the sign.
Yeah, that sign needs to go opposite. What do you think?
Yeah.
Does everyone feel comfortable with that?
Yes.
So this here, and here modifies that. It makes it flip. Okay, so as I scroll down my screen a little bit, oops, get down there. We have a number line. So I know that 0 is roughly there. I have negative 5 there. Should I be that person going, okay, you got negative 1, negative 2, negative 3, negative 4, negative 5, and then over here you got 1, 2, 3. There are some that want you to do that. I just kind of want 0 and you to understand that negative's on the left side of 0 and positive's on the right side of 0. Is it an open or a closed circle? Closed. Why is that? It's equal. Do I want values that are smaller than or less than negative 5 or greater than? Smaller. So I'm continuing to what huge number in the negative direction?
Negative infinity.
Negative infinity. Oh, you guys are awesome. Now here's where a lot of confusion takes place. Okay, so we all agree we're getting down to negative infinity that way? So interval notation will always read on your graphs left to right. So I'm going to come from negative infinity, and I'm going to go to negative 5, and I'm going to use a square bracket at the negative 5. I'm using a square bracket at the negative 5 for what reason?
Because you can reach -5.
Because we can get there. Because it's equal to it, that square bracket. If it's not equal to it, we'll get there, I'm sure. But interval notation, again, you have to read it from left to right, and that's the important way to take a look at it. How far am I? I got like 19 more slides to go. 6 minutes. So, we'll speed through it. You're like, wait. Don't fib to me because I'll know when the bell rings. All right. Ooh, sometimes you have a scenario like this. So order of operations would suggest to do what first? Go ahead.
Distribute the -2.
Distribute the -2. Now you get all these people that are just hung up on going, hey, you know what? 3x minus 2, I should do that first. Well, that's great, but 3 and x aren't like terms to -2. So you can't combine those. So this -2 has to distribute here and here. Does that seem comfortable? Notice I distributed negative to both parts. All right, so I'm going to combine like terms. So 3x minus 2x is 1x. A lot of times in math, we'll say, well, that's just x because x and 1x are the same thing. Are you wrong if you put 1x? No. Some people freak out going, why do you have a 1 in front of it? It's like, because it's always there. And then you get the guy, no, it's a 0. And you're like, oh my gosh. No, you're wrong. The kid who's eating earwax is now confused. You guys are still looking around.
No solution.
What do you mean? I think I'm going to have to subtract x from both sides. And then we find this. Is -10 less than 6? That's true, isn't it?
All solutions.
So it's infinite solutions. So on your number line, if you wanted to get fancy, let's see. Okay, I'm going to try something, and it's going to totally fail. You guys are going to point and laugh, but that's okay. Let's see if this works. We're going to try something without a ladder this time.
Some crazy science stuff.
So it's infinite solution. That should be actually a solid line. Does anybody know how to write in interval notation infinite solutions? Yeah.
Negative infinity with the circular thing,
Huh?
and positive infinity with the
Giddy up. You got it. That just means everything works. And the reason everything works is that it gives us a true statement. If it was a false statement, what would it be?
no solution.
No solution. And actually, we have to say it's no real solution. Okay? Am I going too fast for anybody? I gotta tell you, I love the fact that I'm able to walk around. This is cool. Last year I had the dongle stuck in the end and it was like 10 feet long, so I was like, ah! I felt like, a dog does being arf, arf. I'm sorry, I'm making pictures again. Distribute -2 to both. I think we're okay with this. If I ever cover something and I go too quickly, please have me slow down. Is that appropriate? Feel okay with that? So for this, you have a 0 with a vertical line through it. It means empty set.
What are the funky brackets for?
Just because they're impossible for anyone to draw, so they decided if you have an empty set, you better use these fancy looking brackets. But now I'm going to destroy y'all. So please understand. Look at this. It kind of looks like a forehead, nose. You maybe make a mouth there and an eyeball.
Always
Now all of a sudden you're going to start drawing that in. You're like, yay, I'm happy place.
It's two faces.
It is two-faced, yeah. I don't know what happened. All right, solve each. Oh, now it says it's a compound inequality. So all a compound inequality means is there are two things that are going to happen. There's two events that take place. So does everyone see that we have two inequality signs up there? Is that a comfortable statement for me to make? And one of them is less than and equal to, and one is just less than. Less than and equal is going to be a solid dot, and then just less than is going to be an open dot because we don't include that. But what we do with this type of problem is this is actually two problems that we put together. So the middle section, this 3x minus 6, is going to be part of both of the problems. So you can break it up just like this. Can I get it? Very good. What do you think? Does that seem like an impossible thing? Does everyone see how to split apart? Do all the signs seem to match up like they had?
Yeah.
I like it. So we're going to go ahead and solve each like an individual problem. So I'd add 6 here, so that'd be 9. And then I'm going to divide both sides by 3. Now I'm going to keep this like this for a reason. Okay, just for now. Now, this can be this, but it's okay to keep it looking like this for right now. But it does equal that. Notice I flipped everything over. Yes? And then I'm going to do over on the green. Add 6, so that's 18. Okay? So now we have these two scenarios that take place. I have 3 is less than or equal to x, and x is, which then it means is x is greater than or equal to 3 if you flip the whole thing over. And I also have x is less than 6. So there is a way, one of the other ways of doing compound inequalities is we don't use the interval notation. There's another notation thing. That means you would take this and this and put them back together. But we're not doing it. Okay, it's not really fathomable in calculus, but that's the only reason you want to leave it if you're having it in a different type of notation than interval notation. So let's see how this works. Okay, so I have, all right, 0 here, 3 here, 6 here. I have a solid dot here, and I'm going this way, and I have an open dot here, and I'm going this way. So the region I'm dealing with on this problem is right in between those two. So interval notation reads left to right. So what is my first number we're going to put? 3. Is it square or rounded bracket? Square. Why is that?
Because you can reach it.
Yeah, I'm touching it. So I have from 3, and I'm going all the way up to what?
6.
6. Is 6 going to be a square bracket?
Round.
Why not?
Because it's open.
It's not equal to. So I'm going to use rounded bracket. And that's my interval notation for this one. Make sense? Yeah.
Can't you also just add 6 to both sides when it's one big equation?
I like where you're going on it, and I think that's a really good idea until you start getting really large equations. Like, let's say we have the third root of x minus 6 in between. That's where things are going to get goofy. So it's just best to start the practice of saying, hey, I got two problems, I'm splitting them apart. You're absolutely right what you're saying, that it would work on this type of problem, but if you get into the practice of it, when we get to the more complex things, it's going to totally make more sense for you, okay? So, but you're absolutely right now, but I'm trying to show you the practice that this is the practice that'll work for all, and your practice, once you get to 3 semesters now for math, it's going to be oh shoot, your method is going to catch up with you. Does that make sense?
Yeah.
Cool, all right. But I like your thinking. It's great thought process. All right, this is also a compound inequality, but we have the word and in here. Now, usually the and means you have 2 arrows pointing in opposite directions. It doesn't really, let me reverse that bit. And usually means that you have 2 arrows that are coming together. They overlap each other, okay, when we would graph it. So there are 2 problems here. We're going to work them out. We're going to graph them both. So on this first problem, I'm going to get x is greater than 11. So what I did on that first equation right here is I added 8 to both sides, and I subtracted 2x from both sides. Does that seem okay? All right. And then the second equation, I'm just going to add 5 to both sides, so I'm going to get this. What do you think? So now I want to put them both together. I want to put them both together on the number line. So let's see how this is going to work. Well, I know 0's here, and that's like 11, and that's like 13. Notice I made the 11 and 13 closer together, and then I made the 0 and the 11. I'm good at spacing. All right, so this technically would have been an open circle going this way, and then this would have been a solid circle going this way. Oh no. We're in a lot of trouble here. So I'm going to do my best I can to decipher grammar. You with me on this? Do my best to decipher grammar. So if I were to make a statement, my friend Matt and I went to the store, did we both go to the store? Yes. Does that make sense? If I said my friend Matt or I went to the store, did we both go to the store? No. No, one of us or the other. Okay, so the and is important. So the and means this. We need to figure out what region both of our properties will work on. But right here, this region right here, doesn't work for this problem here. Agree? So then we have to say, all right, where is it going to work for both? Well, it's going to work for both right here, starting at this point and going this way. So I'm going to write my interval notation. And I know I had 2 lines. I just drew them both on the same. But my interval notation would technically be, this is the only region that works for both because I'm using the word and. Both problems have to work when you use and. So that's the only region. So that means that from square bracket 13 to infinity, that's our solution to this problem as interval notation. Okay? You're absolutely right that 11 or greater than 11 does work for one of the problems. But I need it to work for this problem and I need it to work for that problem. So it has to work for this and this. That's why you do your line. Question?
So if you said or, would it work?
Oh yeah, baby, we're gonna get there. We're gonna get there. So, did you like how well I did with my grammar?
Yeah.
My wife would be proud. Would you tell her that I actually spoke correctly for once? I'm sorry, I don't get the I before E rules and stuff like that. It just happens. How many more? Oh man, we got all kinds. All right, I think we're gonna be okay though. All right, solve each. So this is and. So this is going to be the same idea. Okay? And I'm just going to move over because I think you kind of saw the and pretty well. But now I wanted to introduce the F word in math. Fractions. Okay? Sorry. I know most people are offended by saying fraction. So, a few things I'm going to do. I don't like fractions all that much. So there's ways you can clear denominators. I mean, on this one, I would probably do this. And on this next one, you'd have do the reciprocal. So that's going to be this still. That's 6. So let's see if this is going to work. Negative 12 down here, solid dot. I get 0 here. I get 6 here. Again, I'm good at spacing. I want bigger than and I want less than. So that whole shaded region right there is that interval notation where you read it left to right. Square bracket, negative 12. Square bracket to 6. It's supposed to be a 6. And that's how that works. We okay? Can I move on to the next slide?
Sure.
All right. It is decimals. This is going to be done the same way. Are we okay with decimals? Anyone like, oh, I'm so frightened of this? If you are, come see me. But this is going to be the same, just with decimals, but it has the or statement in there. So actually, let me actually hit this because we do have or. All right, so add 0.6 to both sides. Add 0.6, so that should be 2.0. Divide by 0.4, so that's 20 divided by 4, so that's going to be 5 or 5.0. Divide both sides by 0.2. So 6 divided by, that's going to be what, 3? So I have 3 here. I do have 0 down there. And I have 5 here. I have a open dot here. Look where that's going. I have an open dot here. And look where that's going. So I have one part of the region that goes to negative infinity, one part that goes to positive infinity. So we're going to have for our interval notation 2 sets of signs. Still with me on that? So I'm going to go from negative infinity all the way to 3, and it's a rounded bracket at 3 because it's not equal to it. And then I'm going to use the word or for right now, reserving that I might have another symbol for or later. And then I'm going to go rounded bracket from 5 to infinity. So I'm just going to put that this could change later, but as of right now, we're pretty good. Everyone happy? All right. So tonight's assignment, I know I had a couple more slides to go, but I feel pretty good about it, and we can answer those questions tomorrow as well if we get stuck on them. I had 3 and 4 last night, so is it 5 and 6? Okay, so page 5 and 6 will be your assignment. I'm going to hold on to your summer packets. I'll put those in the grade book, but I'm going to hold on to them. If you didn't get them done, get them to me by tomorrow. If you still need extra time, let me know individually, and don't grandstand it in front of the class. Grab your phone. Will somebody grab my phone as well, please?